All right, in this video, we're going to unlock the derivatives for the other four trigonometric functions. We already know the derivatives of the sine function and the cosine function, so we'll take a look at the other four trigonometric functions and figure out how to differentiate those. The general way that we're going to do that is by writing all of those trigonometric functions in terms of sine and cosine, and then using some of the other general derivative rules that we have. And then at the end of this video, we'll take a look at some examples, which will hopefully be a welcome relief, because we don't see a ton of examples in these videos. All right, let's dive into it. First, a quick recap of the sine and cosine function derivatives. The derivative of the sine function is cosine theta, and the derivative of the cosine function is negative sine theta. Maybe you remember the visual, maybe you remembered all the work with the sum of angles identities that we have there, but hopefully we can commit these derivative rules to memory. The one key thing is that theta has to be measured in radians, but that's going to be a standard assumption for us for the rest of the class or for the rest of this sequence of videos. All right, so let's go ahead and start by writing all of our trigonometric functions in terms of sine and cosine. This is a nice little brush-up exercise for you, so pause the video and just scratch these out. It might take you a couple of minutes to remember these, maybe not, depending on how recently you've seen this and how well you retained it. But take a second, think about these, pause the video, and then we'll go from there. And here they are. The tangent function we can write as the sine function over the cosine function. And the secant function is really the reciprocal of the cosine function. The cosecant function is really the reciprocal of the sine function. And the cotangent function is really the reciprocal of the tangent function. So we can just flip that sine and cosine ratio upside down and get cosine theta over sine theta. All right, no big deal. But what we're going to notice is that all four of these are fractions that involve sines and cosines. And if we wanted to differentiate these fractions, these division problems, what could we use? We're going to use the quotient rule here. So hopefully this makes a little bit of sense. Our strategy is to just use the quotient rule on each of these things now that we know the derivatives of the pieces involved, the sine theta function, the cosine theta function. All right, so the derivative of the tangent, let's work through this one together. D over d theta of tan theta is really d over d theta of sine theta over cosine theta. My thetas are pretty bad today, but oh well. What we can do is say, well, u is sine theta and v is cosine theta. And then we can set up our quotient rule by saying u prime is cosine theta and v prime is negative sine theta. You might remember that we have VU prime. So this is going to be cosine theta times cosine theta minus UV prime. That's negative sine theta times sine theta all over V squared, and that's cosine squared theta. All right, so let me just write this all out. That's really cosine squared theta plus sine squared theta over cosine squared theta. What you can notice in a couple of different ways that you could write this out is that on the top here, we'll just say that this is 1. That's the Pythagorean identity. Maybe you remember that. You've probably seen this one before, but that's equal to 1. So we have 1 over cosine squared theta. If you want, you could think of that as 1 over cosine squared theta, 1 over cosine theta squared. There we go. But 1 over cosine is secant. So most of the time, you'll see this written as secant squared theta. Neat. Go ahead and do the same thing for the secant function. Write it out, write out the fraction, set up the quotient rule, and go from there. So while you're thinking about that, I'll just write out the preliminary parts. This is the derivative of secant theta, but remember we said that secant theta was actually, 1 over cosine theta. And so u is our numerator, v is our denominator. U prime then is 0, because 1 is a constant, and v prime is negative sine theta. fill out the quotient rule and see if you can come up with a nice version of the derivative for secant theta. Pause the video and give that a shot. All right, hopefully you've gotten to this part. Sine theta over cosine squared theta. I'm going to break that squared theta, or that cosine squared, apart into two pieces, multiplied by each other, and then I'm going to write sine theta as really 1 times sine. So I have 1 over cosine times sine theta over cosine theta. And now I can see that's really secant theta tangent theta. So this is the way that you'll normally see this one written. So the derivative of our secant function is secant theta tan theta. All right. Go ahead and do the same thing for the cosecant function. You're going to notice that it's going to act really similarly to the secant function. So pause the video. You can probably get this one set up on your own, although I'll write this part out. The derivative of cosecant theta is really the same thing as the derivative of 1 over sine theta. All right, good luck. Pause the video, see what you can do. And there we go. We set up our u and v. Notice the derivative of u is still 0. The derivative of v now of sine theta is cosine theta. Plug everything into place, and it looks really similar, right? Except now we have a negative cosine theta in the numerator and a sine squared theta in the denominator. And so we, again, split that denominator up into the two pieces, split the numerator up into negative 1 times cosine theta, and suddenly we have two fractions, both of which are trig functions. Negative cosecant theta times cotangent theta. There we go. That looks really similar to what we had earlier. It was secant theta tan theta. Now we have negative cosecant theta cotangent theta. Interesting. And lastly, we can take a look at the cotangent function. So again, you can just pause the video and do this one. It's going to go really similarly to what you've already done with the tangent function. You may even be able to just guess this one based on some patterns that you're recognizing. We'll set up the quotient rule again. But now you can go ahead and pause the video and fill all that stuff in, because by now this should be pretty easy. So here it is. It's not too much of a surprise. Everything goes the exact same way. We still have the Pythagorean identity going on in that numerator, but notice we had some negative signs, so we just factor that out. So we get negative 1 over sine squared theta, which we can rewrite as negative cosecant squared theta. Bang. We've got all 4 of our trig functions other than sine and cosine. Here are all 6 of them together. You might notice some patterns here. I've got my, quote, regular functions on the left and my co-functions on the right. And notice the difference in the derivatives. So the derivative of sine theta is cosine theta. The derivative of tangent theta is secant squared theta. And the derivative of secant theta is secant theta tan theta. For all the co-functions, we swap out the derivatives with the co-functions and we reverse the sign. So instead of the derivative here being cosine theta, we get negative sine theta. It's the cofunction version of this. Instead of the derivative being secant squared theta, we get negative cosecant squared theta. Instead of the derivative being secant theta tan theta, we get negative cosecant theta cotan theta. So there's a pretty obvious pattern going on with these. Really, you probably only need to memorize these first 3 as long as you can understand that pattern for how to get from the left column to the right column. Nice. Well, that was weird. I don't know what I was trying to say there. Whatever their case, though, you shouldn't have too much of a hard time memorizing these 6 derivatives. Here are some quick examples using those. So let's just take a look at a couple. You'll notice on this first one in the top left, we don't really have to do too much to it. We just have to know the derivatives of the sine function and the secant function. So we'll say, okay, the derivative of the sine function is the cosine function. So we have 4 cosine t. The derivative of the secant function is secant t tangent t, right? And so that's our derivative. Neat. On the bottom left here, though, what you'll notice is that we have like a little itty-bitty product rule, right? And so we'll say, okay, u is secant x and v is cosecant x. U prime is secant x tan x. V prime is negative cosecant x cotangent x. I'm running out of room. And so we just have to put all these things together. This is going to be pretty ugly, but whatever. I've got cosecant of x times secant x tangent x. Then I've got minus, because there's this negative sign here, secant x cosecant x cotangent x. I might factor out a nice common factor of that secant cosecant. So I've got secant x cosecant x times tangent x minus cotangent x. And you could probably play with this a little bit to get some other versions of it using some trigonometric manipulations, but whatever. Up in this top right, we have a quotient rule. So we'll say u is tangent x, and v is just our regular old power function. So good, x squared minus 1. U prime then is secant squared x, and v prime is our good old-fashioned 2x. All right, so let's go ahead and do this. We need v u prime, so that's going to be secant squared x times x squared minus 1, minus u v prime, that's 2x tangent x, all over our denominator squared. I can do some nice multiplication here. Maybe I'll go down here. And I've got x squared secant squared x minus secant squared x minus 2x tan x all over x squared minus 1 squared. And I don't see anything else to do with that. So we'll just leave it like that. In this last one, I'm actually going to rewrite this as 6 cosine theta cosine theta. And now we can see we can do a product rule on this, right? We'll say u is equal to 6 cosine theta and v is equal to cosine theta. U prime is negative 6 sine theta. I almost forgot that coefficient. And v prime is just negative sine theta. It's a product rule, so we don't have to worry too much about ordering. So remember, we're looking at the derivative of this thing. That is equal to 6 sine theta cosine theta minus 6 sine theta cosine theta. So we could really say negative 12 sine theta cosine theta. That works out quite nicely. So there are our derivatives of each of these. We can use product and quotient rule and things like that. Now that we've got these 6 trigonometric functions, we should expect that they're just going to show up in problems for us, and we should be able to handle those pretty easily. Again, it might take us a little bit of time to just memorize these derivatives, but if you forget them, as long as you know the derivative of sine and cosine, you can find all of these other derivatives by just invoking the quotient rule, which shouldn't be too big of a deal. It's a bit of a time waster, but it's not that hard to do if we really need to, if you're in a pinch out in the wild and need these derivatives. So that's where we're at. That's all we've got for this. In our next couple of videos, we're going to start investigating some more operations and more function types and more ways, more kind of strategies of differentiating things in general. So that'll be pretty interesting to do. It should be a fun set of videos to be looking at. So hopefully you enjoy moving through these. Try and do a lot of practice problems for these because there's a lot of derivative rules that we're just gathering up and expecting us to know. So try and make sure you're able to practice these and commit them to memory. But good luck as you move forward.